Hi, so my name is Ethan, and someone requested that I do a video on piecewise functions. So that's what I'm going to do in this video. And if you already know piecewise functions and you think that this is like below you, you should skip to the end because I'm going to go over like a pretty complicated piecewise function that is used a lot in analysis. So there's something for everyone. So yeah, to get started, I just want to give like a high-level overview of like what a function is. And so you probably learned like what a function is, like y equals mx plus b. That's like a basic linear equation, right? But what a function actually is it takes some input and just maps it to an output. So if we think like abstractly and we have like some like set here, we'll call this like A, and then we have like some set over here, like just like a collection of objects. To make it easy, we can use integers, okay? So we'll have the integer 1, 2, and 3. And then over here we'll have like 10, I don't know, like 20, 30, okay? So what a function does is it takes elements from this input, from the domain, and it maps it to the codomain or the range. So you probably heard domain and range before. And basically that's what it is. So domain is everything that lives inside the input, and then range is everything that lives in the output. So our function here, f is going to map elements from A to B. So this is the notation for defining a function A that maps elements from A to B. And we can like explicitly define what exactly f does. If we just say, hey, 1 maps to 20, 2 maps to 10, 3 maps to 30. Okay, this is a function, all right? What's not a function is if we had 2 separate inputs mapped to the same output. If 2 map to 10 and 20, well, this wouldn't be a function anymore, because as you probably learned in like pre-calc or algebra 2, if it doesn't pass the vertical line test, then it's not a function. So if we were to draw this and we were to actually plot this out, we would have, for the same input, we'd have 2 different y values, right? So it looks something like this, I don't know. And so since it has 2 separate y values, it doesn't pass the vertical line test. So this is not actually a function, because the same input value maps to 2 different output, okay? So this is like a high-level overview of like what a function actually is, like kind of abstractly. You're probably used to just like linear equations like y equals mx plus b, or maybe like polynomials like y equals x squared plus, I don't know, a constant. But this is what a function actually does. And so if we like go along this line, along like this notion, we can think about piecewise functions as more abstractly and think of them as like rules, okay? So let's say you have the basic like y equals 2x. You probably know what this looks like. If this is the x-axis, this is the y-axis. It just looks like this, right? That's a little steep maybe, but this is a slope of 2, okay? So for every one x value, you go up 2 y values, okay? Y equals 2x. So if we want to make a piecewise function out of something like this, well, we define our function f, and we define it for like different conditions, okay? So if we want our function to be y equals 2x somewhere, let's say we want it to be y equals 2x from like negative infinity to 0, right? So we can write f equals 2x for x less than or equal to 0, okay? So all this definition means is that your function, the behavior of your function, when x is less than 0, so just in the negative portion over here, is going to behave exactly like 2x. So this applies when x is less than 0, right? But if we want to change that and we want to say, hey, at 0 and past 0, I want my function to behave like something else, right? Let's say we want it to be like a parabola, okay? So we know that y is 2x when x is less than 0 or equal to 0, less than or equal. But what about past 0, right? Well, we can just add a different condition in here and say, hey, I want it to behave like x squared when x is greater than 0, okay? So when x is greater than 0, instead of y equals 2x going all the way through, it's going to start to behave like x squared. So you're going to get a parabola, okay? So your function now looks like this. Before 0, it's y equals 2x, and then after 0, it's x squared. And so you can get like as rigorous and as complicated as functions as you want. And there might be some like discontinuities that you have to deal with. I think a big question, I don't know, I took this a while ago, so I don't know if I'm recalling correctly, but they want you to find like a certain value where your function is continuous, right? So maybe what they'll do is they'll say like, it's not 2x at 0, or actually no, they'll say like, you need to find the x value such that like these two are the same. So at 0. So what you would do is you would just set them equal, like 2x equals x squared. And then you know that at 0, it has to be equal to 0 so that this condition is true. I don't know if that made sense, but that's like an example problem of like solving piecewise functions. But this is like what a piecewise function is. Yeah, I don't know, if we wanted to get like a little bit weirder, we can even change this. We can let's add a little bit to our piecewise function. We can say, hey, this is only going to be x squared from 0. So x is greater than 0, but less than or equal to 1. So this is going to go up to 1, right? So it's going to behave like x squared. It's going to be this parabola from 0 to 1. But then at 1, we want a different behavior, okay? So it's not going to behave like x squared anymore. It's going to behave like however we want. So instead of x squared, let's say it's just y equals x. So if we just write x here, so before 0, it's going to be 2x. X is less than or equal to 0. When x is between 0 or equal to 1, between 0 and 1 right here, it's going to be x squared. So it's going to be this like curved parabola, right? But then when x is greater than 1, it's just going to behave like y equals x. So at 1, it's just going to behave like y equals x, and you're just going to get this straight line. So this is an example of a piecewise function. Yeah, okay. Okay, so the next piecewise function I want to go over, it's pretty abstract and it's used a lot in analysis, but it's very helpful and it's not too difficult to understand. I think if you were able to follow pretty well what I just explained, you'll be able to grasp what I'm talking about. And so the piecewise function, it's instead of having like functions instead of having like traditional like functions, you define just like pretty much like rules. So instead of x being greater than 0, we're gonna like play on like rational and irrational. So here, I'll explain. So our function, instead of being that other one, we're going to say it's 0 when x is irrational and 1 when x is rational. Okay, you're probably like, what the hell is this? This isn't a function, right? Well, it turns out it is, because the same input doesn't map to the same output. It just behaves extremely weirdly, okay? And it's continuous nowhere, by the way. It's discontinuous everywhere. Because if you think about this and plot it, so if x is irrational, your output is 0. So if your input is irrational, your output is 0. Well, it turns out R is infinitely dense on rationals and irrationals. It's infinitely dense. And so for any like small collection of, like if you take any like interval, you're gonna have infinitely many rationals and irrationals. So you're gonna have infinitely many points where the output of your function is 0 when x is irrational, and you're also gonna have infinitely many points where the output is 1 and x is rational. So what this function does is it infinitely jumps back and forth between 0 and 1 as you like go along. So yeah. So it's defined at 1 pretty much everywhere, and also at 0 pretty much everywhere. But if you pick like an individual point, like say if you pick root 2, well, we know root 2 is irrational, so exactly at root 2, it's going to be 0, right? But if you move anywhere from this point, you're going to get infinitely many zeros and infinitely many ones. And so yeah, I really like this function, and it's used a lot in like real analysis because it has very weird behaviors, as you can tell. It's a very weird function, but if you analyze it, it's very cool. And so yeah, I just want to introduce like concepts like this, and I hope you guys enjoyed. Also, this video was like recommended to be done by one of you guys. So if you have any other suggestions for videos I should do, I would be happy to make them. So just leave a comment below. And thank you.